Hello, good evening, everyone. Today, I would like to present our paper with the title Dynamic Programming Algorithm using Furniture Industry 0.1 Knapsack Problem. So, this is part of research where we are funding by the government, the Indonesian government. We got the funding research from Directorate of Research Technology and Community Service, Directorate General of Higher Education, Research and Technology, Minister of Education, Culture, Research and Technology by the fiscal year contract number 1402, 26 June 2023. So this is our team. We have me, Andita, Natasha Amata, Lawrence Leslie Henry Speedwarners, me, Harko Leslie Henry Speedwarners, and we have a team such as Dr. Arif Ramadan. He is from Telkom University. Dr. Teddy Siswanto from Trisakti University. Professor Teddy Mantoro from Faculty Engineering Technology, Sampurna University. And Dr. Nurul Hudan Rutin from School of Computing Science and Information, Matana University. Okay. First of all, I would like to share about the dynamic programming. Dynamic programming is fundamental algorithm that can be found in our daily life easily. So every time we need the dynamic programming, so we can try to apply these kinds of algorithm. One of the dynamic programming algorithm implementation consists of solving the 0-1 knapsack problem. So this is one of the point in order to try to implement the solving 0-1 knapsack problem. One 0-1 knapsack problem can be seen from industrial production cost. Yeah. So in terms when we want to see the production cost, we can try to use the 0-1 knapsack problem. It is prevalent that a production cost has to be efficient as possible, but the expectation to get the proceed of the product higher. So in terms of searching the best optional, the best implementation for the dynamic program, we can use 0-1 knapsack problem. Thus, the dynamic program algorithm can be implemented to solve the diverse knapsack problem, one which is include 0-1 knapsack problem, which would be the main focuses. And we implemented this algorithm using C language for make easy to us in order to implement it. And also this paper was created with early implementation using dynamic program algorithm, apply using the identification, automatic identification system ICE dataset. So in the first we try to look at these kinds of algorithm as the option to the implementation. This is the type if we want to look at what we can see the implementation. So in this case, we have a data such as we give in this explanation. For example, we have a type of plywood here. From number 1 to number 6, we have a particle board, multiplex, block board, T-block, medium density fiber board, melamine. And if we look at this implementation, each of them they have foot value and foot weight here. For example, for particle board, they have foot value for 100 and wood weight for 4. Multiplex for wood value 115 with wood weight 8. Yeah. Blockboard 155 wood value and 12 for wood weight. Yeah. So each of these optional will be divided based on their wood value and wood weight. So the highest is for the melamine with 245 for wood value and wood weight for 20. So in this purpose, they can try to choose which one the suitable ones based on the optional one to do it, the implementation. Yeah. So like I said, the knapsack problem can be found easily in our daily life, especially 0-1 knapsack problem. Yeah. So it can helpful in various areas. The industry is one area to consider implementing dynamic program in 0-1 knapsack problem. I also already mentioned determine price count as 0-1 knapsack problem. Let's say if we want to implement the implementation, what kinds of the implementation for each using these kinds of type of plywood. So this is become the optional for the implementation. In the furniture industry, to search for the appropriate price for the customer by calculating the production cost that involve material costs, such as like we already mentioned here. Furniture industry must know every type of wood to be used as their material in producing furniture along with their price. One of the wood that usually used as home furniture is a plywood here. So as I already mentioned, this type of wood I already mentioned in this proposed idea. And then after that, we try to make the implementation based the algorithm which already mentioned, where we can see there's some get the position for each of the data. For example, there's a 7 lines here. Yeah, there's a 7 records here from 0 to 6 here, and we have what we call as the wait a minute, what we call it a value. Yeah, it's already mentioned on the previous optional for the item list for the type of plywood. So this is the wood weight here. So we have a wood weight column for 0, 4, 8, 12, 16. So this is will multiply with 4 here, 24, 28, 32, 36 until 4e. Yeah. So to determine which wood combination should be chosen as the material to produce home furniture, like a kitchen set, dynamic program can be used in this 0-1 knapsack problem. So this is the idea how to implement it. Yeah. For example, the weight limit must be 4A. Yeah. To build one kitchen, this is the last optional for 4A to build a kitchen. Given the maximum weight and its worth value and importance, we could run the dynamic programming algorithm based on it. The weight will be counted by multiple of 4 to be more effective. Yes, this is the multiple 4. Yeah. What I mean is from 4 plus 4 become 8, 8 plus 4 become 12, etc. Yeah, until 4a. And the wood include are particle board, multiple block board, and thick block. Yeah, the combination the 4 type of plywood is the most optimal one rather than the other possible combination. With a total weight of 4a, the value range is found in 560. So in conclusion, the step of the algorithm we are going to use are listed as below. Number 1, define the value of each type of plywood. Number 2, calculate how many items will be used as the base of the problem. Number 3, create a table with the size of total item plus 1, multiply with maximum weight plus 1. Number 4, find the maximum value in each iteration to put in the table cell. The last, number 5, the last cell will be optimal value. Then from that cell, we go back forward to determine which item will be included here. So this is the script coding C language for the implementation. If we look at for the main, this is the array here that mentioned about the particle board, multiplex, blackboard, T block here, and also the numbering for, as I already mentioned before, is about the number of wood value and wood weight. Yeah, so they already put become the array here in this case. Yeah, So let's say if they input your maximum weight, so just put the maximum weight and then they will give the result here. So they will run the get knapsack function. This is the function for get knapsack function. So in this case, the get knapsack problem will be running for the option and based on the maximum weight, WT value, and wood here. So this is the implementation for the script coding C language. Yeah. This is the running example for the user here. The user will enter 4A as the maximum weight, and the output will be like the one in the next figures. As already mentioned in the implementation for C language, yeah, yes. The implementation in C language, if we put the maximum weight 4A, the option number will be 560. Yeah. With the wood combination tick block with value 119, block board with the value 155, multiplex with the value 115, particle board with value 100 here. So all of them will be summarized. They'll become 560. So the process will be running in 7.28 seconds. Yeah. So for the next implementation, for example, we enter 100 as the maximum weight. Yeah. So the output will like one in the next figure. Yeah. If we put 100, then the output will be 1010. Yeah. And the wood combination will belong to the, this list here for this all the combination of blocks will be put input become all of audience become the parts of the implementation. For example, for melamine to with value 245, yeah, medium density fiberboard value 205, yeah, thick block with value of 190, block board with value 155, multiplex with value 115, particle board with the value of 100 here. So this is will be running for 2.946 seconds. Yeah. So this is the implementation of the runnings of this algorithm using C language. Yeah. So I would like thanks to listening our presentation. I hope we will give your idea to do the implementation where this dynamic language processing 0-1 knapsack problem can be implemented in many ways depend on the data. Thanks a lot. See you again in another